You have a freezing of moist, hot air, right, in the air, and it condenses and it forms vapor that you can see. And then what happens when you watch that over time? It mixes with the surrounding environment and dissipates, right? This is what water vapor does in a gaseous medium, right? Well, a contrail by definition is that same general phenomenon. The definition comes from condensed trail. Condensation means water. This is what it means. It is water freezing and dissipating and mixing with the surrounding environment. Interestingly enough, the cleanest air from the tests I've done, I did the study to figure out what are the best conditions. The cleanest, coldest, dry air is the best for contrail formation. And it actually fits perfectly if you will observe them under those. So I've done the measurements. This is exactly what fits. Clean, cold, dry air. Okay? Now, let's take on a cloud. This cloud gets a little bit more interesting. And let's bring up the example of the, breathing in cold air. Okay, take another one of you driving. And now you're driving your car. Same general story, right? That I have. Let's say we have a clean car and clean exhaust, and you're up in Michigan. Now, let's just project a little question. And that is, if you're driving up there in Minnesota and it's really cold, take it down to whatever you want, and you're driving down the highway, and just ask yourself, are you leaving a streamer down the road as you're driving a mile or 2 miles or 10 miles? Is there like a stream following you? No, there's not. And it's the same reason. It's the same reason, okay? You have mixing and dissipation that will take place. If it's water. If it's water. Right? Okay. Now let's look at a cloud a little bit. A cloud is interesting in terms of what I see are two main, and more recently even a third one, factor that's important. Number one, you have to have moisture. Okay? But here's the one that gets really interesting to me. You have to have a particle, a solid particle, for a cloud to form. And they're called cloud nuclei. They are incredibly small. We're talking up to submicron range. Oh, let's get the size thing out of the way too, so you have a sense of scale, because I'll be using that term micron probably quite a bit. Your human hair is about 60 to 100 microns thick. Okay? The size that I'm talking about for these cloud nuclei, they're submicron. Okay. Clouds need solid particles for that water to adhere to, and the cloud won't exist without it. So therefore, that's telling you that a cloud is not forming in perfectly clean, dry air, right? It's actually saying sort of the opposite. Needs moisture, needs particles. So the first thing to understand here is that these physical principles are entirely different from one another. These are not the same thing. And part of the dirty water that has come in here on this issue is the blending of these two issues and mixing of the language so that we can no longer make this distinction. Most people are not making that distinction in their mind. They're saying, a trail coming from an airplane, it's forming a cloud. Okay. Well, those don't fit in terms of definition. Now, there will be a way it can work, and I'll try to explain that way to you. There is a way it can work. But it requires a modification of that environment. And the last one is just more recently that I ran into. I'm sort of a book hound. But so there's this book at the bookstore the other day. It's called How to Fossilize Your Hamster. Okay? And this guy, there's a series, a couple of books out there. So I'm not even getting through the pictures, right? But, so he's written 2 books. And I'm reading through this one, and he starts talking about cloud formation. And of course, I'm always trying to learn. And this guy added another dimension that I hadn't really even considered, which is really pretty neat. Because every one of us can start testing what I'm talking about if you care. Everything I do is open. There's nothing about this being just in my domain. And the guy says, hey, you want to make a cloud? Here's how you do it. So guess what he does? He gets a liter bottle of water, one of those little water bottle guys, right? Puts a little bit of water in it. And he drops a match in the water, okay? And then he says, squeeze the bottle and watch what happens. And basically he's saying, I'm making a cloud chamber. Now, these things can get sort of advanced. Cloud chambers can be more advanced physics type thing, but he's giving us a way where we can relate to this on a more elementary and simple level. And what happens is the pressure causes, in this container, you will see a cloud form and disappear depending on the pressure in the bottle. Okay? So pressure is another variable. But the real thing that I want to stress here in this interesting additional analogy this person gave me was the reason that you had that cloud form in that bottle was why? The smoke. The smoke was a source of particles. You remember what I just described, right? It can't be clean to have that cloud. What a great example it is. One time I did some work, this is just a side, but I did some work with a method called electrostatic precipitation. And it's where you take a chamber, and you subject it a high voltage in there, like Van de Graaff generators. Some of you may know those, but it generates high voltage. Anyway, you make this chamber and you drive in high voltage. And what I did, this was one of my first occasions where I was experimenting with this idea, but I filled this up with smoke, and you run this voltage in, it's incredible what happens. That smoke will swirl around and immediately collect on the sides of the container. It's a way of cleaning. Commercial places, commercial factories use it to clean. It's like an alternative to a HEPA filter. Okay. Well, that's the point I'm trying to make here. Is that smoke? It's a solid material. Even though it might be hard for you to get your hands on it, it's a solid material, and you can get your hands on it if you care enough about it. Okay. Now that we have that definition of two basic, completely different physical principles, and it's really helpful and important to me to separate those, because now we have to project a certain scenario coming out, and that is to start explaining what we see. Now, if I have an aircraft, or your car driving down Michigan, or anything which is emitting this supposedly vapor, right? But now it is leaving the 2-mile trail on the ground, or 500 mile. You can see 250 each way. I've done the whole thing. 500 miles across with an aircraft, and it's not dissipating, and it's not mixing. And in fact, not only that, it is extending itself to form eventually a sort of a layer of material. What is happening under those circumstances? How could that happen? It does not fit conventional physics with water vapor. Not by my best analysis. Again, I offer what I do. I've done, the work. It's all there. You can look at my chemistry models of what I've done on this and the amount of time it takes and humidity influence. It just doesn't fit normal physics. But how can it? How can you come up with an explanation for that circumstance? And here's a way, especially if you put together what we've already talked about. If that material that's coming out of that machine is persisting, I'm not using the term persistent continuum, but if it's persisting, what could cause that? Here's what could cause that. If there was a source of nuclei, remember the thing about cloud nuclei? If there was a source of nuclei within that emission, and furthermore, if those nuclei were attracted to water, there's a word called hygroscopic, something that draws water, a desiccant. If it were both of those things, small enough, and especially if it loved water, it fits. That circumstance will occur under those conditions. And this is a physical basis of my entire argument to you, that a primary reason that transformation of the atmosphere can take place is with the introduction of a submicron, in particular metallic salt. That will be something for you to digest. It didn't come quickly to me, but that is the logical conclusion that I've reached of a physical basis that does explain the situation that has been observed. And now consider the fragility of the atmosphere that we talked about. Because another question that comes up on this is you see this